There's one more. So here's this one. There's 2H2O plus 2 electrons going to H2 plus 2OH minus. And then reduction potential for this one is minus 0.83 volts. And note that for this one we have 2OH minus, so that means that the conditions in this case would be in a base. So if you're going to use sulfuric acid, you want to use these two equations. If you use sodium hydroxide, you want to use these two equations. So let's say we're using sulfuric acid as our electrolyte. What reaction is occurring at the cathode? Okay, so we have our, let's say we have in our solution here, we have H2SO4, sulfuric acid, we have our 2 electrodes, we have our power supply here. Okay, so we hook up the negative terminal of the power supply to this one, positive to the other one. So which one's going to be our cathode? This electrode or that electrode? So at the cathode, does oxidation occur or reduction? Yeah, so at the cathode, reduction occurs. And note that the power supply, the negative terminal is hooked up to this one, so that means the power supply is pumping electrons into this electrode. So that means that this electrode is going to be, there's going to be excess electrons here because we're pumping electrons in here. So those excess electrons are going to be transferred from here to something. So is oxidation going to occur here or reduction? Yeah, so this is where reduction will occur. So we have reduction, reaction. This is where our cathode is. And then this is where we have the positive charged electrons. This is our anode. And this is where oxidation occurs. So what's going to be produced at the cathode? H2 or O2?
H2.
Yeah, so H2. So what equation are we going to use of those 4 on the other side of the chalkboard for the reduction? Yeah, so at this one we'll have 2H plus 2 electrons producing H2 gas, and then at the anode, what reaction is going to occur here? H2O going to O2, and then let's see what else is in there. We have plus 4H plus. Let's see. No, wait a second. This should be on the other side. Okay, this should be plus 4H plus 4 electrons.
And it should be a 2 in front of the H2O.
Okay, so this is the reaction occurring here. So we said that for this reduction, this is 0 volts. For the oxidation, that's going to equal, okay, so let's see, for the oxidation, this was plus, for the reduction it was plus 1.23 volts, but for the oxidation it's going to be minus 1.23 volts. Okay, so if we add these together, so we have 2H plus 2 electrons going to H2, and then, so this is 0 volts. And then for the other one, we have 2H2O going to O2 plus 4H plus 4 electrons. E-oxidation, is minus 1.23 volts. So let's add these two together. And before we add them together, we need to because we have 2 electrons transferred here, we have 4 electrons transferred there. Do we need to multiply this one by 2? So when we do that, let's see, our balanced reaction, we're going to have 4H plus 2H2O going to 2H2 plus O2 plus 4H plus. So note that the H pluses cancel out. And now we're left with our balanced overall reaction split water. And then for E cell, so although we multiply this by 2, we don't multiply our reduction by 2. So for E cell, it's E reduction plus E oxidation. So that's going to be 0 minus 1.23 volts. And this is going to equal minus 1.23 volts. So this is the voltage that we need to apply to split water. So in lab, we'll look at the reactions for the basic solution. We should get the same answer. And I'll apologize to you now because I know you were really looking forward to taking a quiz, and obviously we're out of time to take the quiz, so we won't take the quiz. We won't take the quiz. We still have to talk about batteries and some other things. So we'll talk about that next week. So I'll see you guys in lab in about 15 minutes or for the 2 o'clock lab.